Have you ever wondered how firefighters can walk into a burning building? The flames can be hundreds of degrees, hot enough to melt metal. How can a person possibly survive in that environment? The answer is an amazing piece of engineering they wear every day. When a firefighter gets a call, they have to be ready for anything. The biggest danger they face is not just the fire itself, but the incredible, overwhelming heat. Your body has a normal temperature it needs to maintain. If you get too hot, your organs can start to shut down. A fire creates heat in multiple ways. There's the heat you feel from a distance, called radiant heat, and the hot air that rushes around, called convective heat. A firefighter's suit has to protect them from all of it. It's not just one layer of fabric, but a high-tech system designed for survival. Let's break it down from the outside in. The first part of the suit is called the outer shell. This layer is the first line of defense. It's made from special, fire-resistant fibers. You might have heard of materials like Nomex or Kevlar. These materials don't catch fire easily. Instead of burning, they char and thicken, creating a barrier against the flames. The outer shell is also shiny for a reason. Its reflective surface helps to bounce radiant heat away from the firefighter, just like a mirror reflects light. But stopping flames isn't enough. The suit also needs to manage water and steam. Underneath the outer shell is the second layer, the moisture barrier. This layer does two very important jobs. First, it stops water from the fire hoses from getting in and soaking the inner layers. A wetsuit would be incredibly dangerous. Water conducts heat very quickly, and if it turned to steam, it would cause severe burns. The second job is to let sweat escape. A firefighter works incredibly hard, and their body produces a lot of sweat. This barrier is breathable, allowing sweat vapor to get out, which helps keep the firefighter from overheating from the inside. Now we get to the most important part for heat protection. The third layer is the thermal barrier. This is the thickest, most insulating part of the suit. It's a fluffy layer of material designed to trap air. Air is actually a very poor conductor of heat. By trapping pockets of air, this layer dramatically slows down how quickly the heat from the fire can reach the firefighter's skin. It works just like the insulation in the walls of your house, keeping the heat out. Finally, we have the innermost layer, the one that rests against the firefighter's own clothing. This layer is designed for comfort. It's soft and smooth, so it doesn't chafe or irritate the skin during a long and difficult job. It also helps to wick moisture away from the skin, pulling sweat towards the outer layers where it can evaporate. So you have 4 separate layers, each with a specific job: reflect, repel, insulate, and comfort. And this same science applies to the rest of the gear. Their helmet protects their head from heat and falling objects. Their gloves use the same layered system to allow them to handle hot equipment. And their boots have thick, puncture-proof soles to protect their feet from both heat and sharp debris on the ground. Every single piece of the equipment is a carefully designed system. The big insight here is that complex problems are often solved with a layered approach. One single material couldn't do everything. Engineers couldn't find one fabric that was reflective, waterproof, breathable, and a great insulator all at once. So instead, they created a system. Each layer solves one part of the problem perfectly. By combining them, they created a solution that is far more effective than any single component could ever be. This is the power of materials, science, and engineering. It's about understanding the properties of different materials and combining them in clever ways. The firefighter's suit is a wearable machine, a shield built from scientific principles that allows ordinary people to do extraordinary things. It's how science helps heroes face the impossible and return home safe.